Great. So let's welcome Michael. Thank you.
Hi, everybody. I'm Michael, obviously. Thanks, John, for inviting me today. I've had some great conversations this morning with a few people. Looking forward to more this afternoon. So very inspiring. So I decided to call my talk Tinkering with Intention, and I'll talk a little bit about the title in a second. I'm hoping to create sort of a dialogue, too, towards the end of the talk, so have a conversation with people as well. I didn't really have a thesis for this talk this morning when I woke up. I wasn't really sure. I was, just kind of general talk about my work. But when I was waiting in the lobby here this morning, I got here a little early, and I was looking at it wasn't a recent article from Communications from the ACM, but I think it was from a November issue. And I opened up to an article. It was about this new idea that Disney is promoting called Touché, which is this new capacitance way of controlling computers. And they had this quote from this guy, Mark Weiser, who used to be the manager of Xerox PARC, and this is from 1991. But the quote was, "The most profound technologies are those that disappear." And I realized that
a buddy of ours in a faculty.
Oh, okay, great. Okay, so I'm in the right place. Excellent. All right. Well, my thesis is the exact opposite of that, in that I think it's actually great if the computers aren't disappearing, but rather are very visible and very tangible and very much part of the material space. And before I start, I just will talk a little bit about sort of what I do now. I do have an arts background. I have a degree in sculpture. I became an elementary school teacher in New York City. I did that for 10 years. And I started working with Mitchell Resnick at the Media Lab back in '97 or so as part of an NSF grant, which I'll talk about in a little bit. And then eventually, Mitchell and I were talking, and I decided to apply to his research group at the Media Lab, and that's how I ended up there. Since the Media Lab, I've kind of been doing lots of different things. One of the reasons when I was 17 I decided to go to art school is because I thought when I go to art school and become an artist, that means I can work in lots of different areas. And that sounded great because I was interested in lots of different things. That has turned out to be very true, and sometimes it's a bit of a pain because I've got lots of different things going on. These are all things that I'm doing now or have done in the last 6 months. So Future Makers is a mobile makerspace that I started with a guy named Matt Barinholtz. I'll talk a little bit about that later. That's in the Baltimore, D.C. area. I'm also a visiting artist at the American Visionary Art Museum, which is a museum in Baltimore. I do workshops there with people, usually around technology, electricity-oriented things, which is not typical for that museum, but getting more so. I'm also part of a founding group that's starting a new children's museum in Montgomery County. That's going to be in Silver Spring. I'm also on the Scratch team still at the Media Lab. So for those of you who don't know Scratch is a programming environment for novices. I'll talk a little bit about it in a bit. But I still work with the Scratch team. Mostly doing lots of workshops. So last November, I went to Shanghai to do workshops with a bunch of teachers. I'll show some pictures from that. And then I'm also collaborating with a group in South Africa called Beyond Education, which is trying to extend learning in informal situations throughout various townships in and around Cape Town. And last year also I had a residency at a university in Istanbul, and I had a residency at a university in the Netherlands. So I've cobbled lots of different things together for my life, and it's great, but it's also really, really complicated to keep everything straight and orderly. So these are just, and I'll talk a little bit more about specifically those things, but my real focus is about materials. That's what I'm really interested in because of my arts background, because of the idea of making and creating. Materials are really what I think about most days. If you walk into my studio, there's all kinds of crazy things in there that my kids get into, but that's great. And it's just what I really am passionate about is using different types of materials and finding ways of learning about them, making things from them, learning more things. And I think that's where the sort of don't hide the computer, don't hide the technology idea comes into place. And I'll talk more about that. But before I really start talking about materials, I need to talk about this tinker idea, because the tinkering, the word tinkering is being used quite a bit now in the whole maker movement culture.
Isn't that a new book?
I'm sure there is. There's probably 3, actually. You know, it's so the tinker, for those who don't know, was this character who kind of roamed the countryside and would fix things for people. If people needed their pans mended or they needed a cartwheel fixed, they would fix it, and they generally would fix it with whatever they had at hand. They would have some tools with them and some materials, but they would try to fix it, you know, in a kind of what would be called a bricolage or ad hoc way. And that's essentially what the tinker was. I don't like the word tinkering. I really don't like the word tinkering. And there are lots of different reasons why I don't like it. One reason is that it implies to me, you know, not really getting anything done. You know, when you say that somebody's just tinkering, they're just kind of playing around with something, they're not actually really accomplishing anything. And I guess that's a little bit why I call the talk tinkering with intention, because I actually think it's good to tinker and play around with things, but goals are also kind of important too, especially for young people in learning. But tinkering is a prevalent word. You know, you've got tinkering schools now. There's a few of them around. There's tinkering camps. Make magazine, I think, every other month has an article about tinkering. And then there's the Tinkering Studio, which is a place at the Exploratorium in San Francisco, which is a museum of science, art, and human perception. In 2011, I was actually an artist in residence in the Tinkering Studio. And my friends know about how I feel about, my friends who started the Tinkering Studio know how I feel about the word tinkering. But it sounds to me just like a 4-letter word. You know, I just don't, you know, I just don't enjoy it. But I don't know of a replacement word for it. So, and it's just a word, so it's not that big of a deal. But I did learn something interesting when I was in the Netherlands back in October. The Dutch word for tinkering is Froybelen, which comes from Friedrich Froebel, who created the first kindergartens. I'll actually talk about Froebel in a few minutes. But so Froybelen is the word, but the Dutch actually use it as a derogatory word. They'll say, oh, he's just a Froybelen, meaning he's just really just a tinker. He doesn't really ever actually accomplish anything. So it's this derogatory term that they use, and that's exactly what I think about the word tinkering. So, but again, you know, it's just a word, and I'm happy to live with it, I guess. So just going back to the tinkering business, I see it as about a learning process. And I hope what to get across today is a little bit about that learning process and the way in which different types of digital technologies fit into that learning process. Some of the ones that I worked on when I was at the Media Lab. One way to think about tinkering is sort of contrast it with planning. Obviously planning is really important. I'm not saying that planning isn't important. I think Rodney Brooks, who ran the Artificial Intelligence Lab at MIT, he used to say planning is what you do when you don't know what to do next. Which is kind of a cute little thing, but so tinkering and planning. So in planning, you do it once and you do it right, and it's targeted, top down. School curriculums generally are all about planning. You have planning days for teachers, and you usually will design something and then build. Designing is the planning part, whereas tinkering is actually about iteration. And that's the part that I really like, is that iterating part. And some of the tools I'll talk about today and some of the activities and spaces that I work in are all about iteration. And it's open-ended, bottom-up, there's free play, and you design as you build. So that's just a contrasting thing. Just to talk a little bit about what happened to the tinker. I mean, manufacturing happened to the tinker, that's one thing. Things started to be, you know, produced on a mass scale, and so tinkers weren't really needed anymore. If something broke, they would throw it away and just get another one. And then, you know, there are some points that we can make about how that manufacturing affected schooling and education, preparing people for manufacturing. And so tinkering, the idea of tinkering, the tinker, that kind of faded out. Obviously, with this maker movement thing that's happening, and how much of a movement it is up for debate. But you know, tinkering is becoming much more prevalent. Obviously, people are using the word.
Hey, Michael.
Yeah.
Are your kids boys or girls?
My children?
Your children, yeah.
My children are both girls.
They're both girls.
Yes.
Are they?
They're 7 and 4.
How much have you been subjected to the fairy movies?
With the 4-year-old, tons. The 7-year-old, not at all.
Because I just keep thinking about Tinkerbell and how it's all now about the Tinker Guild.
Right. Well, my wife loves the movie Tinkerbell for that exact reason. Because she is a tinkerer and she solves these major problems for them in the movie. I do like that movie. In fact, I actually, in some earlier talks, I had contemplated one time putting like a scene from that movie in the talk. I didn't ultimately, but my kids do like that movie. They did. Well, see, my older daughter, my 7-year-old, She's not into fairies, but she's an inventor. I mean, she's a builder, an inventor. An engineer type. My other daughter is a ballet dancer, and so it's just one of those things.
Well, my husband, daughter, and I all dressed up as Tinker Fairies.
Oh, excellent.
Halloween, so I'll have to show you that.
I would like to see that. Very cool. I love it. Cool. I mean, it's an interesting phenomena, and I do think it's cool that movie sort of ties in with what's going on with the movement. So again, tinkering not just as a process of learning, but also as this relationship with materials. And again, that's sort of primarily what I'm interested in. The tinker had his tools, but also the materials that the tinker used to solve certain problems. I'm going to talk a little bit first about the tinkering studio. I'm not going to kind of go in a linear fashion through my life and my work here. I'm just going to talk a little bit about what we do at the Tinkering Studio. I still collaborate with them a lot. It's part of the Museum of Science, Art, and Human Perception in San Francisco. For those of you who don't know, it was started by Frank Oppenheimer back in the early 1970s. He's the brother of J. Robert Oppenheimer. Frank Oppenheimer and J. Robert Oppenheimer were blacklisted after World War II. Frank Oppenheimer was a professor actually at the University in Minnesota, but he lost his job when he was blacklisted, and he became a high school physics teacher. And he created all these really interesting ways of teaching physics to kids and having kids build things and build experiments. Ultimately, people suggested he should start a museum, and he started the Exploratorium in San Francisco. And it's still considered to be sort of the preeminent science, hands-on science museum in the country, if not the world. Some friends of mine started an experiment there called the Tinkering Studio, where instead of going to the museum and just seeing exhibits, you would actually go into the Tinkering Studio and build things and create things and make things as a visitor to the museum, which was a challenge because usually when you visit a museum, you look at an exhibit for a few minutes and you move on to the next thing. With the Tinkering Studio, we were inviting people to stay a really long time in that space. I tease my friends and tell them that the Tinkering Studio is the Exploratorium inside the Exploratorium. And it is a little bit like that.
Just out of curiosity, how many people have been to the Exploratorium? It's San Francisco, right?
Yeah, San Francisco, yeah. It's in the process of moving. It's closed right now. It's going to open up back in April. So if you're there, again, they're moving. The space that they used to have, which is in the Palace of Fine Arts, Frank Oppenheimer managed to get from the city for $1 a year for rent. But George Lucas built his Industrial Light and Magic studio a few years ago in the old Presidio, which is right next to the Palace of Fine Arts. So the city realized that they could get lots more money for this space than $1 a year. So the Exploratorium was given 2 piers on the other side of the peninsula on the bay side to create a new museum, and that museum will be opening up in a month or so. So anyhow. A great, wonderful place, and I think the new space will be even better in a lot of ways. So the Tinkering Studio, this is kind of gives you an example of, it's this space, it's literally on the floor, and you can walk in. Sometimes there'll be organized workshops going on, sometimes there'll just be things to play around with. The Exploratorium, Frank Oppenheimer set up a really phenomenal system whereby high school students would become what's called explainers, and they would wear these special vests, and they just kind of wander around the museum showing people different things about exhibits on the floor. And so there might be explainers in the Tinkering Studio. There might be a visiting artist in the Tinkering Studio developing projects. So some projects might be explorations with light and shadow, A lot of these things are very low tech, I would say, or mixing sort of high tech and low tech in some instances. Another popular thing is a giant marble wall fort, literally a wall where people can come in and just build. And this is a particularly good example of that iteration process. You'll see a kid sitting there for 2-3 hours just trying out different things, different ways of building marble walls. There might be like a sewing a circuit workshop going on in there where people will sew, learn how to sew different circuits. And then this is like a really simple one, but it's great. This tops activity where there'll be tons of materials for building tops, and kids will just experiment building different types of tops. And again, that iteration idea is kind of central to this, because the thought is that you build a top, see how it behaves, then build another one, or change that one, and continue that process and try to give people the space to do that. And then drawing machines is another popular one. This is just a vibrating motor. It's kind of a vibrating robot that has a pen or pencil, and it draws really cool, interesting things on a sheet of paper. So we might engage people in that. But the ultimate goal is to get people to see that we learn through making, and we learn through materials. So that's kind of the idea of the Tinkering Studio. I'm going to step way back to my art school days. When I was in art school, I was trying to figure out what I was going to do with myself. Like a lot of young people in art school, I wanted to make socially important art, that not only expressed my angst about the world, but also, did something that was socially meaningful. And I met a guy, an artist who's a relatively famous artist named Tim Rollins, who started an organization in the South Bronx called the Art and Knowledge Workshop. And it was a place for high school kids to come, and they would read books, things like Kafka's America or The Scarlet Letter, and then they would design paintings around those books. And he actually paid them to do the paintings. He paid them by the hour. And the paintings got quite famous. He got quite famous. The paintings have been in major exhibitions at Museum of Modern Art, Prado in Spain, different places. But he really believed that if you're going to make political art, it's really about how you make that art, not what the art is about itself. And that really inspired me actually to get into education, into teaching. So I taught for a number of years. And then one day I met some people who were talking about this guy, Seymour Papert. And I had no idea who Seymour Papert was, but they were talking about him like he was some kind of god or something like that. And I discovered more about Seymour Papert, and I found that his ideas were very much in line with my own ideas as both an educator and a maker, artist type person. And that's namely this idea that people learn best when they're making things, when they're actively constructing their own knowledge. He had worked with Jean Piaget in Switzerland for a few years, and then he went to start the Artificial Intelligence Lab at MIT in the 1960s. And his profound thought was that, one day computers are going to be all around us. This is the age of mainframes, the giant computers in rooms where you need to stick punch cards in. There's probably some people in the room who've actually programmed with punch cards. So he really believed that computers would be everywhere one day, and the question for him was, what would kids do with the computers? And he wondered if children could actually use the computer in the same way that he used it, as a tool for exploring and understanding the world. And that's how he came about to create, with a number of other people, the Logo programming language, which is just an environment or language for writing computer programs that was very popular with kids. It originally started with programming this little device down here, which was this turtle, and kids would write programs to move the turtle around in geometric shapes. So they would understand that, to write a program for the turtle to make a square, they would write something like repeat 4, move 10 steps this way, write 90 degrees, so do it 4 times. He was very famous for saying, 2 wrongs don't make a right, but 3 rights make a left. That was kind of one of his catchphrases. So Seymour really kind of pioneered this idea of children and computers, children using computers in ways that were exploratory and inquiry-based, and ultimately maker-based, because kids were making things with these computers. So this is a little bit like what a sort of more contemporary version of Logo might look like. You see some procedures over there on the left-hand side, and it got, eventually a company started in Montreal called LCSI, which developed this product called Microworlds, where kids could actually program shapes and characters to interact and do things. So it became somewhat popular, somewhat not. There's some disagreement about whether or not the Logo experiment really worked. I had never heard of Logo until I heard of Seymour Papert. I did not have any of that exposed to me prior to hearing about Seymour. So anyway, I became really interested in constructionism. I became really interested in people working at the MIT Media Lab. That's where Seymour was based. His research group was called the Epistemology and Learning Group. Anyway, that was his group's name. So I started working with one of his proteges, Mitchell Resnick. Mitchell was working with Seymour, got his PhD under Hal Abelson and Seymour. And I started working with Mitchell. I actually just took a bus to Boston one day and went up to Mitchell's office and knocked on his door and showed him some of my portfolio as a teacher. And we started talking. And from that point, I worked with him and other people in the research group on various ideas. And I'm just going to sort of show some images from the Media Lab, because the sort of the material richness of the lab. This is a relatively new research group. For those of you who don't know, the Media Lab is broken up into about 30 research groups, 8 to 10 students in each research group. And usually the professor that runs the research group has a particular passion. Mitchell's, of course, is learning, creative learning, and digital technologies. This is actually Leah Buckley's group. She's a relatively new professor there. She runs the high low-tech group, which is a great group. And the thing I just love about like one of these images is the sewing machine next to the 3D printer. I just think that's so cool. So, very material rich thing. But there are other groups here. Some of you may know who Hiroshi Ishii is. This is the Tangible Computing Groups area here. Todd Mackover's Opera of the Future group. He's a musician and composer. And then, of course, we have, state-of-the-art machine shops and things like that. So if you liked building things and making things, it was definitely the place to be. But anyway, when I started working with Mitchell, we started working on this project called Beyond Black Boxes, which was this National Science Foundation funded project to have kids build their own scientific instruments. And at the heart of it was this little device here, which we called the Cricket, which was this little microcontroller, basically. The Cricket, the research that went in the Cricket ultimately ended up in the RCX Mindstorms, which is this popular product that Lego produced. The way the Media Lab works is that there are members and sponsors that give money to the lab every year, and they then have rights to the technology and the ideas that come out of the lab. So Lego then took, I was actually a Lego, when I got to the Media Lab, I was a Lego fellow, so Lego actually paid for my graduate work. And I got to go to Lego a few times and work with them. But they took, they took the research from this little device here, which you can plug sensors and motors into, and then you program it using a little infrared beamer device. And kids would embed these in things and make their own scientific instruments. The classic example was a little girl who built we showed her how to build a thermistor, temperature reader, and you can actually graph with this. It can take in data over time, and then you can upload it to a graph. And at one point we uploaded a graph, and the temperature is staying, she left it overnight in her kitchen, the temperature is staying relatively the same, and about 2 a.m. there's this huge spike, and then it goes down, and she went home that afternoon, and it turned out her father had made popcorn in the microwave, and she had set it on top of the microwave, and so there was a disturbance in the temperature. So, I mean, things like that we were doing with kids, having them explore how to collect data, how to analyze data, so on and so forth. So then eventually I ended up working with Mitchell, going to the Media Lab as a research assistant, and Mitchell's really fond of talking about the creative society. There's this knowledge society or information society, but he really feels that it's important for people to be creative because we can't really predict what the future is going to be like exactly. There's statistics that go around that 60% of today's first graders will have careers that don't even exist right now. So how can you actually prepare those kids for those careers? So it makes more sense to prepare them for being creative thinkers. And so that really is Mitchell's, passion and what he really thinks about on a daily basis. And this is his research group is called the Lifelong Kindergarten Group. And we've had discussions about whether or not he should change the name because kindergarten is much different now than it was when he named the group. I don't know if any of you have had kindergarten. It's a lot more like traditional schooling than you realize. When Froy started the first kindergartens, he really started them as places where kids could play and experiment with different materials and different ideas. They could sort of do that iteration process. They could tinker. I'm assuming that that's why the Dutch have the word tinker as Freubelen in Dutch, because Freubel was all about tinkering and playing around and understanding materials. He invented a series of manipulatives, 20 plus I think, that are sometimes referred to as Freubel's gifts. Blocks for understanding different types of physics, shapes, various different devices for hands-on creation and building. So Mitchell's question with the Lifelong Kindergarten Group is, what are the Freubel's gifts of the 21st century? What would they look like? And these are a selection of some of the things that have come out of not just Mitchell's group, but a few other groups at the Media Lab. There's a few of these that I've worked on specifically, which I'll talk about in detail. But I can just say this is one guy named Hayes Raffel, who was in Hiroshi Ishii's group, created this thing called Topobo. It's basically a toy kit where kids can put together different creatures, and you can actually program the movement of it by moving the different limbs. This is a project by Dave Merrill, who is in the Responsive Environments group, called Siftio, which is actually now a product you can get. It's a gaming kind of learning tool. This is a project by my office mate at the Media Lab. He calls it flow blocks. It's a way for kids to play around with systems thinking, to understand stocks and flows and how systems actually work. And then the ones that I'm going to talk about sort of specifically are this new generation of Cricket, the Cricket thing, which I'll talk about, and then that's called the Scratch board, which runs with Scratch. And then this is probably the most recent thing that's come out of Mitchell's group, which is Makey, which was designed by Jay Silver and Eric Rosenbaum, who are two of Mitchell's students now, PhD students there. And I'll show you some projects that were used with some of these things. Probably the biggest thing, though, that's come out of Mitchell's group in the last 5 or 6 years is Scratch. And Scratch is a programming environment for novices. It's basically what we call building block programming. So you have different palettes of blocks that would control different aspects of things on the screen, different characters or backgrounds, and you drag and drop these blocks in different places and build procedures. Scratch was originally an NSF-funded project. It grew in popularity for 2 reasons. One is that it was given away for free. So teachers, anybody could take Scratch and use it. And the other thing is we internationalized it. So there's a little button in the interface. When you click this button, it would give a drop-down menu of about 70 languages. And if you clicked on one of the languages, it would switch the whole interface into that language. So it immediately just became a big hit around the world. One of the other things is Mitchell's group built a website, kind of like a YouTube for Scratch, for people to share projects. And they're now, I think, well over 400,000 registered users, and I think there's over 3 million projects now on the website. So it's gotten quite big. Scratch 2.0 is about to be released. It's been worked on for a couple of years. It's, instead of it being, an application that you download, it's all cloud-based. So that should be interesting to see how that transition happens.
Quick question.
Yeah.
In the original design of Scratch, were they thinking of having that social sharing? Because I mean, it's almost like before viral became viral, right? And
Yeah,
it's been, I think, really kind of critical to its success.
I totally agree. Yeah, it wasn't in the original vision, but it was pretty quickly that was thought. I mean, that was sort of the key thing.
It's just amazing.
Yeah, so I'll tell you the history of Scratch. So when I got to the Media Lab is just when we were starting to think about building Scratch. The way Scratch came about is that Alan Kay, when Mitchell's group goes on retreat every year, go on retreat with Alan Kay's research group. And Alan was looking for something new to do because he had just finished working at Disney with his group of people. And Mitchell was suggesting that they work together. And Alan said, why don't you guys just build your own thing and see what you come up with, and we'll talk later. So that's where Scratch sort of originated. Scratch is built on top of Smalltalk, which is the language that, or it's actually built on top of Squeak, which in itself is built in Smalltalk. So, but anyway, and the reason why Scratch exists is because Mitchell, about maybe 15 years ago, got a bunch of money from Intel Corporation to start these after-school computer clubhouses, generally in underserved communities around the world. There's about 150 of them. And what we found in the computer clubhouses is that kids would come in and they would do things like use Photoshop and put the picture of their head on the body of Arnold Schwarzenegger. Like that was the limit of their computing. And we just felt like there were all these great computers in there that Intel put in, but they weren't computing. They weren't using the computers to their full extent. So that's why Scratch was developed, to create a programming language that we could then put in these computer clubhouses. My office mate, Oren, came up with the name Scratch. It comes from DJing, scratching, because we were trying to appeal to high school kids at the time. I would say that the programming environment is now geared a little bit to maybe middle schoolers and a little bit younger even to some degree. But anyhow, that's sort of where Scratch kind of originated from. So this is a picture of the site that I was just talking about. People would, you become a member and then you could, upload your projects, and there are tutorials and support and galleries and all kinds of things. And this is just a screen grab real quick of Scratch 2.0. You can see, look, this is, the 1.4 version. 2.0 is much different. It has all the same functionality, if not more, but it's all cloud-based. So the 3 things that generally Mitchell talks about a lot in his group, and I'm sure you probably do here, so it's not, but this idea of low floor, like making things really accessible for people so that, particularly for kids, that they can get immediate feedback in what they're doing. And then this idea of high ceiling, that you have lots more room for exploring more complex ideas. And then wide walls, which would be, space for developing a range of ideas. So, for instance, with Scratch, you can start with a very simple program. You can make a very complex, say, video game or simulation. But you could also develop sort of an interactive story or a simulation or a game, a piece of art, interactive artwork. I mean, there's a wide range of things. You can do sound in Scratch. So there's a wide range of things that you can actually do in Scratch. Also, another thing that Mitchell talks about is this idea of the creative thinking spiral. And I think this goes back to talking about iteration and tinkering a little bit. because he thinks that people, when they're engaged in creative thinking, they usually start by imagining something, and then they create something, then play with it, share with it, and reflect on it, and then start the whole process over again. So can you create tools that allow people to do that, to build something and play with it and share it, and then begin that process again? So that's a big part of what goes into the thinking when these kinds of systems are being designed. This is what is now known as the Pico Cricket. It is related to the Cricket. I actually brought one. So you can see it's this little device here. Obviously, it looks much different than this. When Lego came out with Mindstorms, Mitchell, the rest of us in the group, didn't really like what they had done with it, in the sense that it was really hard to get started with this. A lot of Mindstorms kits we found, just from anecdotal evidence, were being put up on shelves and left there. To get from, so there's a green button here to run your program, but to get from building something to then running your programming it, then running your program and making something happen, there were a lot of steps, and it actually wasn't that easy. This became really popular with hobbyists and dads around the world, but not so much with kids, which it was geared towards. It was called Mindstorms because Seymour's first book was called Mindstorms, which was his book that he wrote in 1980 about computers and kids. So it was named after Seymour, for Seymour. So this device, we really just didn't think it worked very well. I don't know the full extent of the story, but Mitchell went to Lego and said, we can do this better. And so Lego actually gave some money to the group to start a spin-off corporation called the Playful Invention Corporation. And we created a whole new device. We actually rebuilt the whole thing, including the programming environment. And this actually is a precursor to Scratch. This was actually the first building block programming environment that we built. So again, just the idea is that you would take this device, and let's say I've got, I did bring some. I'm not going to demonstrate it. If people afterwards want to see a demo, that's fine. But you just would plug in, wires. It didn't matter where you plugged it in, because all the sensors had their own intelligence on board, so it knew, whether or not it was a light sensor or a, sound sensor. And then you could program this light sensor to say, here's a digital display, and I could plug in a digital display, and I could just start capturing, light data through these two ports. And then I could add in a motor, and I could add in a conditional that says if the light data drops down below this value, turn on the motor, so on and so forth. But something else that we included in the kit, which doesn't come with Mindstorms, and this goes a little bit into the thinking that I'm trying to get at here. The idea is we included a sound module so you could create different types of sounds and music. We also included a bunch of tricolor LEDs so you could do all kinds of light experiments, or make wearable jewelry or what have you. And then the kit, this is what it actually looked like when you would get the kit. It would come with some Lego pieces. Because Lego allowed us to do that. And then it would also come with craft materials, because we were trying to expand sort of the range of what people could actually build with. When you got a Lego Mindstorms kit, it was all about building robots that crash into each other. And if you look at the box, that's what it looked like. We were trying to appeal to a much wider range of people. Probably the most ingenious thing about the Pico Cricket, I think, which my friend Stephanie Hunt came up with, are these two little loops on the side. So it does have a Lego plate in the back, so you could attach it to Lego or something, but these two little loops allowed people to sew things around it or to tie things around it, and it completely just changed the sort of framework in which the computer was actually being used. So this is sort of like how we went from this little device here, the Cricket here, to the RCX, to this. There are other steps in between, but that's just sort of the general idea. I think I have an example. So this is some of the things that come in the kit. So motorboard, display, colored lights, sound box, touch sensor. I will say that these are not being sold anymore. There was one problem with these, and that is the expense of the kit. So Mitchell and I would go to conferences, or we'd be at places, and teachers would come up to us and say, that's so great, how much are they? And we would say, oh, they're $250. It wasn't like they're only $250. We just felt really bad. It's a lot of money. And so that was problematic, obviously, for schools and other folks. Then a few years ago, there's a particular part in here that was discontinued, and for us to replace that part with a different part, it would have jacked up the price even more. So these are actually not being built anymore, which is frustrating to people who did invest in kits. That was kind of problematic. But you have new platforms now. I mean, Arduino has this whole family of things now, and I'll talk a little bit more about Arduino in a bit. But Anyway, that's the kit. But this is a project that I did in Iceland a few years ago. I went to Iceland 3 different times and did some different projects there. But this is one, Hugmyndagsmiðjan means idea factory. And basically, I was given a gallery in Reykjavik and just kind of created a makerspace for a week for kids. These were like 10 to 14-year-olds. Maybe 25 of them, who came into this space, and the idea was for them to just invent using the Pico Cricket. So we had computers around with the programming language. We had lots of different materials. We had spaces for them to design and think about what they're working on. These are some of the inventions that they came up with. This is a hypnotizing machine. It's kind of fun. This was an automatic spaghetti twirler, the one with the fork. There's some other ones. This one was quite classic because it was an alarm that when the sun we would set off an alarm basically when the sun hit the light sensor. The problem is we're talking about Iceland. So there's part of the year where that wouldn't actually work. So it was an alarm that only worked half the year. But that was like an interesting conversation to have with the kid who built it. So now I'm just going to kind of move into a different project. This is one that I did last year. And it's related to Scratch. And this other device that I've worked on, which is mostly spearheaded by a guy named Aman Milner, who was a graduate student in Mitchell's group. This is called the Scratch board, or sometimes it's called the Pico board, because it did come out of the Playful Invention Company. But this allows you to actually hook things up to the computer so that you can control things in Scratch, the various different characters in Scratch, using these different sensors that are on board here. So there's a push button, there's a microphone, light sensor, a little slider, and then we have these resistance sensor connections, so you can actually add in your own sensors if you want to build your own resistant-based sensors. So I did a project last year. Eric and I went, actually, that's Eric Rosenbaum down there, who's still a graduate student in the Media Lab. We went and did a project with a new group at a university in Istanbul who was developing a gaming lab. And so this was a video gaming workshop. And people just use different types of materials just to kind of think outside the box, so to speak. Literally, I guess, in that case there. A lot of people, we sort of had this idea of cabinet of curiosities. Thanks, okay. So we had cabinet of curiosity idea where people would embed these games and things like that into the boxes. But people designed all different sorts of things. So this is actually a controller for a Space Invaders game that he built, but using water as the controller. So just kind of thinking outside the box a little bit. And this is just a short video. I'm actually going to skip ahead because just due to time. And then this is a sound workshop, which we did. Eric and I, again, went last fall to the Netherlands together. And this time we used Makey. How many people here have heard of this thing? Makey? As Eric would say, I got quite famous on the internet, is kind of how Eric puts it. This is a device that essentially just takes over your keyboard. It allows you to plug different types of resistance sensing materials into your computer to control what normally the keyboard would control. So you could write a computer program where if every time you touch a space bar it makes a sound, or you could use a piece of software when you hit a space bar it makes a sound. Instead you could build your own space bar. The idea being that it was kind of a material-rich place where people could play with building their own instruments in this particular case. We focused on music because Eric is a musician and is writing his PhD thesis on music. So we asked the question, could you tinker with music? Could you play with music in this way? The title of the workshop was Music as Material. And these were all music and technology students at a university in Arnhem, Netherlands.
And can I just add too with the Makey? We do have a few in the hackerspace, and they are profoundly delightful. I mean, like,
they're really simple and yeah.
Really simple but amazing.
Yeah.
And to be able to just plug it in and take control of the keyboard allows you to do so many cool things. And if you go online, there's just a great video describing Makey, where people are interacting with bananas, staircases. It's really, really, really cool.
Yeah.
We got some. We're going to use them with kids' team in a couple weeks.
Great. Yeah, it's really well done for, like simple, really easy plug and play kind of thing. It's great. And there's ways to extend it too. It actually also is kind of a full-blown Arduino programming microcontroller as well. So it has some advanced capabilities too, which is great for these students because they were able to push to the boundaries a little bit in building some of the things that they built. This is a short little video. I will play this one. You may not be able to hear it. We did all these strange music exercises too. But you can get it gets a little surreal. That was a micro drum set. People were hooking things in the building. You could literally have the whole building was a resistance sensor, so you could kind of play the building in a sense, which is a David Byrne idea. This is essentially like a complex looping mechanism. They had a whole video component that was all being controlled by the Makey. Some projects got pretty abstract. I have no idea what this is in the video, by the way. I must think I should edit that out. I just don't know what it is. I have no idea. It's in there. I don't know. It's like this apparition in the video.
It's like a seance.
This is even stranger. This is somebody playing a Leonard Cohen song on a stepladder. The stepladder is the instrument, the piano. Balloon instrument.
So did you bring all these materials in there for this?
A lot of them, and then we got some when we were in the Netherlands. We actually did another project in Amsterdam too before this, where we collected a bunch of stuff. So, but most of it, yeah. This one really freaked me out. So this is one actually that used the Arduino. Some people were really pushing, you know, their coding abilities were really good. So this one actually used an Arduino specifically for doing a sound percussion thing that he built. We had a big performance afterwards, invited the public. So those are recordings of her voice singing the notes, the chords. When he plays the right chords, the piano would sing the notes.
That's an analog hammer piano.
Yeah. And this is just something we did at the very end. These stairs, that's the high school where MC Escher went to high school. So we went there and did this, you know, those stairs, you know about his staircase drawings, that was inspired by this. And then these are people playing with helium balloons. Anyhow, so now I'm going to talk a little bit about this project I've done in China for the last few years. I went to China back in 2006, 2007 for a while. One thing about working in China is you end up working with lots of people. That probably goes without saying. What I helped them do is actually start a center called the LEAD Center. LEAD stands for Learning Through Engineering, Art, and Design. It's not a makerspace per se. I mean, it's kind of a makerspace, but not quite yet. They're not quite there yet. But it's a creative learning space where they do things like clay animation and they do robotics and things of that nature. When I first got to Hong Kong, I was going to do a robotics workshop. What they didn't tell me is that I was going to do it with 300 kids. So I actually did, and I have if anybody wants to see the movie, they made a movie of it, which is, I would definitely say it's the highlight of my life as an educator. Because it actually worked. It was a 2-day workshop. So these 300 kids came in. I had a translator. There were teachers there with them who were helping me, but they didn't know about programming and about, you know, building robots and things like that. And we had a lot of Lego and a lot of different other types of material. And kids actually built these things together in teams, and they just kind of and we did it in a way that was, we have a phrase that we use sometimes in the Lifelong Kindergarten group, exhibition, not competition. So the idea is to kind of move kids away from competing against each other. It's not like things like First Lego League aren't good. We like First Lego League, but we also like the idea of kids just exhibiting things and talking about and sharing ideas. So this is more of an exhibition style thing. So at the end, you know, kids actually shared things with each other up on the stage in that other room. Basically, I was down in a room in an auditorium with 300 kids, and we all went up to the gymnasium where there were a bunch of tables set up, and for 2 days we built robots. But it was great. So in November, I went to Shanghai to do a teacher workshop on Scratch. What they didn't tell me is that there are going to be 120 teachers in the workshop. So I did a workshop with 120 teachers. And there were things like, you know, computers breaking down. I had to fix computers on the fly. We did a sharing thing also, just kind of gather around computers and people shared, kind of crazy stuff like that. My work at the American Visionary Art Museum, this is an idea that I think really works well with tinkering. These wind tubes that we developed at the Exploratorium, basically a tube of wind, and kids can build and create flying machines that fly up in them. And what's great about it is that they make something work or do whatever they want to do, and then they can change it really quickly, put it back in, and try it out. And so you find that kids will just stick around these things for hours at a time, just playing with different materials. And then I also do workshops that are more technology based. I did a workshop last summer where we actually took old CD players and we dismantled them and reused some of the components in them to build basically automata, different theatrical things. So here's a couple of ninjas fighting inside a box. This is some other thing. So. And then Future Makers, this is kind of coming to the end here. This is this mobile makerspace that I've started with this guy. Well, actually, Matt Barinholtz started it, and I've sort of jumped in and joined him. This is us getting our van and trailer ready at about 3 o'clock in the morning to deploy to a space. We do workshops in lots of different places, after schools, community colleges. We just had one at Carroll County Community College last Saturday. We basically load up the van. We do different types of projects, everything from wood making to microcontrol programming to sewing. So like that's a van full of 30 sewing machines. So we did a big sewing project. I had to charge up all our drills for one thing at one point. That was probably 2 o'clock in the morning. So we deploy out to places and create makerspaces in places. And so this is an example of, this is at Montgomery Community College about a month ago. This is a room that I worked in. When I walked in the room, it looked like that. And then I had to transition it to that. Really quickly, and then had kids actually building little machine devices, machine inventions using different types of motors, gear-reduced motors. And so this is all the same, that same project at that same space. And again, material-rich environment. And then another thing, we have 15 artists right now that work with us, that work with Future Makers, and we do this really cool thing once a month where we get together and we brainstorm new workshop ideas. And that to me is the best time. We're just kind of sitting in Matt's studio, building things, thinking about how to use 3D printers and laser cutters and things like that in interesting ways.
One thing I really enjoyed about the public library setup that you guys had, I mean, it was so rich, right?
Yeah.
It brought so many people over to you. I mean, it's just very physically attractive. There's so much going on, but also the mix of materials, like you said.
Yeah.
The low tech and the high tech.
Yeah.
And that combination is really neat. Like there were like actual wood making
Yeah.
type things and materials. Like people could kind of auger.
Yeah, right.
Wood next
Yeah.
to Arduino and Makey.
Right, and I think that's important to me. And I guess that's maybe what I mean about my thesis about don't make the computer disappear. Is that I like that it's around. I like that there are microcontrollers and things like that around. So makerspaces, just really quickly, because I'm running out of time, but makerspaces are popping up all over the place. You have one here, actually. And it is a movement. I don't know what to make of it. I don't know, what it's going to be like 2, 3, 4, 5 years from now. But it's an exciting place to be. Somebody was asking me, maybe it was Michael was asking me, how did you end up in the maker movement? And if you just look at my trajectory of my life, it's like, it just went right to this kind of thing happening, which is great. It's very exciting to be part of it. So these are just examples of some maker spaces in various different places. And one place that's really trying to push makerspace even more is library settings. So Matt and I have been working a lot with libraries in Maryland particularly. We're actually going to have a Maker Fair event on June 1st at the Enoch Pratt Library. So if people want to come to that, that's going to be great. This is actually in Westport, Connecticut. This is probably one of the more well-known ones. That's a makerspace in the middle of the library. And that's a permanent makerspace. That's sitting there. And I believe they do things like let people check out Arduino kits. So you can take out an Arduino kit, build something with it, return it in 2 weeks. So that's a pretty well-known one. There's another one in upstate New York that's getting a lot of attention. And they're popping up all over the place. And definitely in Maryland, the library people in Maryland are really pushing it. So Matt and I did a maker event for librarians, for 100 librarians back in November. And we've been to maybe 7 or 8 libraries now so far, setting up maker spaces in libraries. So it's definitely something that's happening. But last point, so makerspaces, oftentimes when people think about makerspaces, they think about all these great new technologies, laser cutters and 3D printers and shop bots, little tabletop CNC routers, that kind of thing. I actually taking this from Matt. Matt has this great thing that he does when we give talks. When the refrigerator was first invented, it was this really amazing thing that completely changed the way we cook and the way we think about food and the way we relate to our house and our kitchen. Before that time, it was a lot different, if you can imagine what it would be like not having a refrigerator. And there might have been a time when people got all dressed up and stood around and stared at the refrigerator because it was such an amazing thing, quite remarkable. Well, if you think about these new technologies that are coming out, people are doing that now. They're standing around staring at their technologies. You know, they're staring at these 3D printers and watching them do their thing, and it is quite magical and cool. But that will go away. You know, now, pretty soon these things will become part of our everyday life. And that's great. I guess my point is, you know, to make sure that they don't quite disappear, because I actually think that there's a lot of magical things that can happen with them. The Arduino platform is a good example. You know, if you haven't programmed with Arduino, it's fine, but it's just a great, great tool. There's lots of different families of Arduinos to program with. And it's just a really nice platform, and it's just a great way to play with materials and computation. One issue with Arduino, particularly for the work that I do, is it's challenging for young novices to actually get into programming Arduino. So there's a group of people who have been thinking about this, and one idea is this ModKit idea, which is a programming environment based on Scratch to program Arduinos using a building block programming language. And that's being developed by a group of people in Cambridge, Mass. And then also processing. I don't know if you've heard of processing. It's a great visual programming language for artists and designers. It was designed at the Media Lab originally. It's also has a very large community of users. But again, you know, if you're not a programmer, you know, or a Java programmer, or have some sense of programming, it's very hard to get started in processing. So Evelyn Eastman, who is a former student of Mitchell's, is actually developing a building block version of processing. So sticking together, it's called design blocks. So a way of creating designs. And I see I have 1 minute and 20 seconds left, so that's going to be the end of my talk. So that's generally the point. And then, I don't know if you want questions, or you know, there's not much time left, but if people have questions, and I, of course, will be around. So
You're
and you can always email me. I'm actually pretty good at answering email.
You're leaving, I think, today at 3 or something.
Yeah, a little before 3, just a few minutes before 3 to get. Yeah, I got to pick up a kid from the bus stop. So.
Questions?
Yeah.
All right.
Okay.
I have a question. How could we maybe get the Makermobile over here? I think it would be kind of fun.
Oh, that would be cool. Well, one thing, we are working with the iSchool folks. So I did this talk as part of Mega's class that she's giving on universal usability, I guess is the name of the class. And Matt and I are working with a group of students who are, we've talked about, they want to create an accessible makerspace. So how would you create a makerspace that's accessible to a wide range of people? So, and that's something that Matt is actually quite passionate about. So we've been working with them. That's actually going to happen at the DC Public Library at some point again, in that same space, the same main area, the MLK branch. But yeah, we could definitely come over at some point.
Yeah, keep me updated if there is a time in which, you know, you're at a library or something. I think that our community would be interested in attending one of those.
Cool. Okay. One thing, a couple things I do want to say. So I'm going to do a course at the second week in August for high school students on meta design. The idea, I'm going to teach them how to. My time's up. Teach them how to think about designing for designers. So that's something that people are interested in, that idea. And another idea I'm working on, so I worked on this book for Scratch that came out last year from No Starch Press. I'm working on a new book that's specifically about interaction design, particularly physical computing and how to use some of the microcontroller stuff with Scratch. So if people are interested in those ideas, definitely email me, because I'd love to collaborate and work with people on that.
Great. Okay, Tim.
Well, I'm just overwhelmed with not really quite being able to figure out how to process everything you've presented.
I'm sorry.
Things I'm interested in.
Okay.
I'm very excited by what you've presented. So I have two overall questions. One is, I'm curious about sort of the role that sculpture, your background in sculpture, has played in sort of what you're doing now.
Yeah.
And actually, I'll just leave it at that.
Yeah, I think it just comes back to the materials idea. So when I was doing sculpture back as an undergrad many years ago, I went to SUNY Purchase art school outside of New York City. And I was building sculptures I was mixing paper and welded steel, actually. I was making my own handmade paper and doing these elaborate sculptures. And just, you know, the material aspect of those two experiences of, you know, using a Decalin mold and water and then going and using a welder with metal, you know, that range of experience, I think, just makes materials fascinating to me. And so I think for me, it's really about material-rich environment. And that's why I say I see the computer as another material, not as a tool, but as a material. And that's why I say I don't want it to disappear. I don't want it to be hidden from view. I want it to be very much part of what it is that I'm making. As an artist, I see myself as, I guess what you'd call a bricolage artist or a kludge artist even, I oftentimes just sticking odd things together to make. Right now I'm building a record player that plays the same record on both sides. Crazy idea, but I'm doing it because it's fun and interesting and a good challenge. So just materials and mechanisms too. I mean, definitely I like time-based art, so using light and motors and sound, those kinds of things. I see sound and light as a material also. So next week I'm doing a workshop at AVAM called Visionary Sound, and we're going to build these sound instruments by circuit bending various different crazy things. And we're also going to use piezo mics and do some of that, mix that in with some of the stuff we're building.
I think what you're doing is wonderful, and I just hope we can find ways to get it to work over here and create, a community around it. I just want to, have you thought about the term, you don't like tinkering? How about thinkering?
Well, that's pretty good, yeah. Maybe I could, yeah.
It sort of gets your intention in there.
Right, yeah, that's true, actually. Yeah, I could see that, yeah. There's a group in New York that runs a pop-up makerspace. They call it Makery, and their group is called H-Tink. So it's H-Tink, and I think it's sort of like pulling the H out and switching it around. I'm not sure how you pronounce H-Tink. I think they just, I don't know. Anyhow, they're doing cool stuff, though.
Maker ring, but make ring.
Yeah, okay.
Has make ring, has the kind of, instead of make a ring,
right.
Make ring.
Yeah, it's funny. I mean, I don't call myself a maker, whereas Matt, my collaborator with Future Makers, he calls himself a maker. I just call myself an artist. I don't know why. It's just they're just words, right, at the end of the day. But anyhow, yeah.
The artist label will likely, stay in fashion for perpetuity, whereas maker is somewhat of a trendy label.
Yeah, but
we talked about with this, but they
right.
can always just scrape off the
right. Yeah, there you go. Yeah,
label.
Yeah, exactly. I mean, artists also though. When I tell people, say, "Well, what do you do?" I say, "I'm an artist and educator." When you say artist, that conjures up something in particular too. I mean, the fact that I'm now a visiting artist at the National Museum of Outsider Art. We were just having a conversation about this actually before that talk. It's yeah, I don't know. I mean, it's all these words,
Right?
Yeah, exactly. So.
Well, thank you so much for
Yeah.
coming.
Well, thanks for having me. I appreciate it.